So welcome to the short video about using the algorithm for determining argument validity or invalidity. Let's go right to an example. You can refer to the notes for the steps. Here, we're going to look at an argument that has P implies Q for its first premise, P or Q for its second premise, Q implies P for its third premise, and therefore P if and only if Q as its conclusion. So we have premises and we have a conclusion, and that's going to help us when we set up our truth table, because the first step, of course, is to create a truth table that has a column for every premise and the conclusion. We only have two variables for statements, P and Q, so we're only going to need 4 rows for our truth table. And of course, we set it up in the canonical way. Under P, we write true, 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 true. And under Q, we write true, false, true, false. We'll need a column for P implies Q, a column for P or Q, a column for Q implies P, and a column for the conclusion, P if and only if Q. Now we can quickly recall how to fill in these columns because we have now learned how to deal with the conditional and the biconditional. P implies Q only fails if the hypothesis P is true and the conclusion Q is false. It's the only time it fails. Otherwise, it's true. P or Q is true in the first 3 rows, and it only fails if both P and Q are false. Q implies P, being an implication, only fails if the hypothesis, which is Q, is false, and the conclusion, P, is true. That happens in row 3. In every other row, Q implies P is true. P if and only if Q, we discovered, is true exactly when P and Q have the same truth value. That happens in row 1 when both are true, and it happens again in row 4 when both P and Q are false. In rows 2 and 3, where P and Q have opposite truth values, the biconditional is false. So we have just executed step 1. Do label the rows, the columns for your premises and your conclusion. Why do we bother to do that? Because the next step is identifying rows of interest. When we try to identify rows of interest, we are looking in the premise columns. We're looking for rows where all 3 premises are true. Well, in row 1, all 3 premises are true. We're not looking at the conclusion. We're only looking at the premises in step 2. Well, in row 2, premise 1 is false, so it's not a row of interest. In row 3, premise 3 is false, so row 3 is not a row of interest. And in row 4, premise 2 is false, so it is not a row of interest. We only have 1 row of interest, so this will be easy. In our last step, we're going to check, is the conclusion true or false in the rows of interest? Hey, the conclusion is true in the only row of interest. So finally, in step 4, we can write our decision, our answer. The argument is valid. Because the conclusion is true in every row of interest, namely row 1. By the way, in the notes from the video lecture for day 3, when I did work through our example for determining argument validity, and I wrote the decision, I forgot to write the word true. Those notes have been amended. I believe I said the word true in the video, but I did not write the word that the conclusion is true. in the actual notes. So do check that out. Now, let's take a look at one more example and execute the 4-step algorithm for determining argument validity. Example 2. All right, what are our premises? Well, this argument looks like this. P implies R, Q and R implies P, therefore Q. So again, we do have 3 premises. By the way, most arguments have at least 2 premises. There are a couple of very small little arguments called specialization arguments that only have 1 premise. All right, so we're going to execute the algorithm. We need 8 rows because we have 3 statement variables, P, Q, and R. So, all right, let's go ahead and fill in the columns for P, Q, and R in the canonical way. Please always use the canonical setup for your truth table. So under P, we'll write true, 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 false, 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 false. Then, so half of 8 is 4, so it's 4 truths followed by 4 falses. Split 4 in half, half of 4 is 2, so 2 truths followed by 2 falses. Repeat, 2 truths followed by 2 falses. And then when we split 2 in half, we get 1, and that means we are now in our last column, and we're alternating true, false, true, false, true, false, true, false. And look, the variables are in alphabetical order, P, Q, R. We always start the columns with true when we're setting up the initial columns for the statement variables. All right, so what else do we have here? Well, P implies R is premise 1. We'll need a column for that. Q and R is premise 2. We'll need a column for that. R implies P is our 3rd premise. And Q is our conclusion. Now, we've already got the conclusion written. We don't need to repeat that. But I like to have my conclusion column to the right of my premise columns. So I'm just going to go ahead and repeat the column for Q. By the way, don't forget to label the columns for your premises and the column for your conclusion. Here we go. P implies R. So true implies true. We got to be careful to look in the right columns. P is the hypothesis, R is the conclusion. Of course, true implies true is true. In row 2, true implies false, of course, is false. In row 3, true implies true is true. In row 4, true implies false is false. And again, we've seen this before in the video for day 3. In rows 5, 6, 7, and 8, sometimes I put a little horizontal line through there to settle my eye down. The hypothesis P is false, so the if-then is true by false hypothesis. Here, it's Q and R. Oh, hang on. I want P and R. My bad. P and R. I wrote the problem down wrong. Let's change that to a P. I want this to match the document in the Goode Stuff folder. Okay, P and R. So P and R are true in row 1. P and R are true in row 3. And in every other row, at least one of P and R is false. So the and operated statement fails. We can see right now, we will have at most 2 rows of interest because premise 2 would have to be true in every row of interest. It's only true in 2 rows. So let's go ahead and fill out the column for R implies P. R is the hypothesis, P is the conclusion. True implies true is true. Here R is false in row 2, so this is true by false hypothesis. In fact, R is false also in rows 4, 6, and 8. So R implies P will be true by false hypothesis in those rows. In row 3, true implies true is true. In row 5, true implies false is false. And in row 7, true implies false is false. So we have now executed step 1. We have our truth table with a column for every premise and the conclusion, and we have labeled them as such. Because although in this particular case, it's not going to be that hard to see the rows of interest, we do need to settle our I down. So the next step will be to identify the rows in which all the premises are true. Well, in row 1, all 3 premises are true. So yes, that is a row of interest. Row 3 is also a row of interest. Those are the only rows of interest because in all the other rows, at least one of the premises is false. And now we go to step 3. Let's check. Is the conclusion true or false in each row of interest? Well, in row 1, the conclusion is true. In row 3, the conclusion is false. That's all it takes, is one row of interest with a false conclusion to render the argument is invalid, or to render the argument invalid. So here's our decision. Our decision is the argument is invalid. Because there is a row with all true premises and a false conclusion. And I'll even cite the row just to be sure that the reader knows, i.e. row 3. And that is the way that we execute our algorithm for deciding whether an argument is valid or invalid. Okay, I hope between these 2 examples and the end of the day 3 lecture that's in the YouTube channel, you have got enough information to execute this algorithm. See you next time.